All right, hi guys. Today we're going to chat about, we'll call it a twist system, a limb twist system. We chatted a little bit about it at the end of class on Monday, but just to recap or present it for the first time, we have created these limb systems now, where we have a shoulder, elbow, and a wrist joint. And then you'll recall we've created an additional hand joint which carries the rest of the hand system with all of the finger controls. But we do have that wrist joint and the hand joint. They were duplicates of each other. They sit in the exact same place, same orientation. And the way that we have been tying those together is we've taken the IK and the FK system have combined together to constrain the RK system. So that one will follow RK will follow either RK will follow either the FK or the IK systems. And then we take that hand system and we constrain the hand system to the RK system. So it will follow whichever one of those limb systems is activated. So the issue we're going to try to alleviate today is when we skin them. When you skin, if you think of your own arm, right? If I have a joint here and I move my hand up or down like this, you can see the deformation is fairly limited to just this section here. We get that little bit of crease in my elbow, right? Crease at the top. Same thing when you go side to side, right? It's limited really kind of to this area of the wrist, which is great when I'm doing this. But then if I were to take that control and rotate my wrist, right? You can see what's really happening here is not my wrist is rotating, it's this whole section of my arm. Anatomically, you've got the radius and the ulna, the two bones inside of your arm that kind of sit side by side, and when you twist your arm, one of them rotates over the top. Okay, so really, again, when I twist my wrist, you'll notice, let's just say that the control here at the wrist is twisting 100%. So we're seeing the wrist rotate 100% with that control. If I rotated it 180 degrees, right, my wrist is rotating 180 degrees. Down here at my elbow, nothing's happening. So there it's affected about 0%. And then there's kind of this gradation along my arm. So we'd say maybe in the middle, we're getting about 50% rotation, right? Maybe 75 here, maybe 25. But there's this gradation of influence from the wrist working its way down the elbow. So we need to be able to go like this and have the influence isolated just to this section of the wrist. If I were to twist my hand control the way it is right now, only that part of my hand and then this little section of wrist would twist, creating, we call it a candy wrapper effect, but it would basically turn in on itself. We call it a candy wrapper effect because you think of that like a piece of taffy or something. You twist it, right? And in the middle, it just kind of bunches up into this little tiny strand of paper or plastic or whatever the wrapper is. Obviously, we don't want that to happen when we turn our wrist. So we're going to create a new set of joints and some behind the scenes, not controls, but maybe influences would be the right thing to say, that will automate this procedure for us. So whether we're moving our hand like this or like this, we're going to get the right sort of deformation out of it. That's the goal. So to do that, let's start by just kind of whiteboarding what we're doing here. The idea here is we've got, let's just draw what will symbolize our arm. Okay, and here we've got the hand coming off of the fingers. Okay, something like that. And let's do our joints in green. So this would be our elbow joint, and then our wrist joint, or that arm 3. We've got going like this. And then on top of that, we've got that additional hand joint, and then all of the fingers, right, and the knuckles of the fingers, so on and so forth. Obviously, we're not really paying attention to the fingers because we have more joints than that in our hand. We're focusing more just really at the wrist and this forearm, the lower part of your arm. So what we're going to do is utilize aim constraints, which we haven't really used before. Aim constraints sometimes are called look at constraints. They affect the orientation, the rotation of an object. And the way it works is you have a target, right? And that affects another node. And when the target moves, the affected or constrained object will rotate so that it's continually oriented at that object. We're going to talk about there's an additional up axis as well, which will, the constrained object is always going to point, but an up object will allow us to also rotate that node that is being constrained. Okay, so that third degree of axis that an aim doesn't really give us, we're going to add that. That's actually what we're utilizing to do the twisting of our arm. We're manipulating the up axis. So we'll chat about what that means. So the way we're going to do this is we're going to add, I call it a twist system. It's just a series of helpers, a system behind the scenes that's going to do the twisting and the calculation for us, and then we're going to feed the values from that system back into some additional joints that we create. So the way we're going to do this is we're going to create a couple locators. And if you remember a locator, it's just a transform. It just has a little kind of like a 3-axis cross sort of shape attached with it, but that's just so you can see it. It doesn't render, it doesn't do anything. It just gives you something you can look at. So what we're going to do is create a couple locators. One's going to be at the wrist and one's going to be at the elbow. And we're going to orient those exactly the same as the elbow itself. So they will all have that same orientation. And what we're going to do is constrain the one at the elbow. I'm going to call this the target because the one at the wrist is going to point back to the elbow at all times. So that's our target. We'll call this target locator. And this one we're going to call the aim locator. Okay, so this is going to aim back at the target, like so. But we want this to always follow the position of the arm or the elbow. It's going to stay locked to the elbow, 100%. So we're essentially, we're just going to parent constrain this to the elbow. And I should specify at this point, we've combined our FK and our IK systems into the RK. That's going to follow. That's the joint chain either that's going to skin the mesh or that's going to, we're going to continue building on that for other things that are going to skin the mesh. So at this point, we're making the changes or these constraints to the RK elbow, not to FK or IK. We just want this to follow the arm, the final state of the arm. So that's going to be constrained right there to the elbow. Okay. This aim locator down here, we want this position of this to stay locked to the hand control. So when we rotate the hand, this hand joint is going to rotate as well. We want this to follow. We said before it's like 100% influence here at the wrist. Right. So again, we want this locator just to follow exactly what the hand is doing. So we are actually going to take and constrain this one directly to the wrist. Okay. So one follows the elbow and the other is going to follow the wrist. Okay. That's fairly straightforward. So that aim locator, this one's not a parent constraint. We're going to get into the aim constraint issue or topic. Really, we're just going to point constraint this one for now. So point constrain to the hand joint. Okay, not to the wrist, but to that hand joint. You remember, a point constraint just takes care of the translation of an object. So it will stay positioned wherever the hand joint is, wherever that hand control goes. Okay, and then there's one additional locator we're going to create. I'm actually going to do it off to the side of the hand. Right here, because of the way that I've drawn this, I'm going to draw it down here below the hand. This is oriented exactly the same as these two other locators. And so I'm just going to move it down in whatever axis this is. And I'm going to call this the up locator. Okay. And the up locator, similarly, we want that to follow the hand as well. Okay. So this one we will actually parent, keeps moving. Parent constrain to the hand. Okay. So as the hand rotates, I mean, this locator really essentially is just kind of locked to the wrist. This is kind of an interesting behavior with an aim control, or an aim constraint, excuse me. I mentioned already is the fact that we do have some control over the twisting itself. So, and what happens is the main axis that we define is always going to point to the target. But it's like there's a secondary point, there's a secondary aim happening, right? And I already said what it does, but that this main axis will be maintained 100%. That's always going to point in this direction. The secondary axis, or this up axis, it's going to do its very best to have the secondary axis that we define to do the same thing. It's always going to point at this up locator as far as it can. If my locator's over here, for example, it's not going to rotate this so that it's going to be pointing down like this, because that would affect my ability to have my main axis pointing back here to the elbow. Instead, it's going to say, well, okay, I can't rotate this direction because that would affect my main axis, but if I define, right now it's this vertical axis, if I define that this should be pointing down at this up locator, then it's going to say, well, okay, it's down. Where I have this and where I have this, it's going to solve exactly the same, because in relation to the vertical axis of this locator, it's down. Okay, and we'll do this obviously in a practical application here, but just know that the aim axis, it does its best to point in that general direction, but it will not aim directly to that up locator, or the up target. We'll call it the up target. Okay, so let's go ahead and get rid of these extra little notes that I drew in here. Okay, and those are our main components there. So we have an aim locator that's going to be positioned at the wrist. It's going to have a point constraint, so it stays locked, not to the wrist, I'm sorry, to the hand joint. It's going to stay locked in place. We have the target locator that's going to be locked or constrained to the elbow joint. Okay, and then we have the up locator that we're going to put, you could put it to the side, you could put it above or below. It just needs to be at an offset from the original location so that the aim locator has something to point at. Okay, and then the last thing we're going to add is one additional locator, and it's going to be right in between the aim locator and the target locator. We're going to hit it like 50% right between the two. And this locator, we're actually going to do a little bit of math. We're going to take the rotation of the locator at the wrist, and we're just going to divide it in half, and we're going to assign that rotation here to this, I'll call it a mid locator. Right, it's going to have 50% of the rotation. And that will be our influence object for the forearm. That's what's going to slow it down. What's cool about this system is if you wanted to, you could add as many influences down the arm as you want. I could add another one here and another one here, and this one I could assign 25%, and this one's 75% rotation of the hand. I could go further than that if I wanted to. If you're going to have an arm that's going to do some really crazy, like rubber hose type animation, you could use these not only for the twisting of the arm, but for some extended deformation as well. So within a game environment, or really a lot of environments, this one in the center, we're just going to focus on twist. This is going to do the job just fine. So we'll just focus on that one. So 50% rotation of the hand. That's what's going to be assigned there. And it sits in the middle of the elbow and the hand. Okay, so this is how we set it up. So now let's just actually go through the process here. Okay, we'll pull up my hair, and I've got our little Takato, whatever his name is, rig. And let's go ahead and hide our geometry for now and show our joints. And these are my RK joints in the arm. And let's see if I can take that hand joint, and let's just, maybe I'll decrease the scale a little bit on that so we can see it a little bit better. Let's just go to 1. All right, maybe I'll just hide my controls for now too. So let's just start by creating those locators. So create locator, and I'll just call this left arm twist aim loc for locator. Okay, and we'll just duplicate this a few more times and just do some renaming. So I've got the aim locator, I've got the target locator, the up locator, and then the mid locator. Okay, and I mentioned before, these not only have to be positioned in a specific place, but we're going to orient them all to be the same as the elbow, and we'll group them up as well. The convenient part about this is if I just get a group to inherit the rotation, and all of these are children of that group, they're all going to have the same rotation. Right? They'll adopt the rotation of the parent. They'll all be oriented exactly the same, and I don't have to deal with parent groups for all of them. So I'll just create a new group node. So I'll just press Control G. We'll just call this left arm twist group. And I'll just take that group, shift select my elbow joint, and we'll do a match transformations. Okay, and that will position and orient that group at the elbow joint. Let's take all of those locators now. Let's just parent those directly under this left arm twist group. So if I zero out my orientation now, actually I meant to do this for all of them. I can select all of them and zero out my rotation values. Okay, with those zeroed out, remember they will adopt the transformation values of the parent. They'll be exactly the same. So they are now oriented the same as this group, and we can verify that once we start snapping them into place. So the aim locator, I'll just activate the move tool. So I've got that selected. I'm going to hold V and I'll middle click, just wiggle the mouse button, and that will snap it there to the wrist or the hand joint. And you can see there, I've got my move tool set to object or local orientation. You can see that it does have X pointing down the chain and Z is pointing down in the world axis, the way that I've got this joint set up. Rotations are set at 0. I only have a translate X, which is the position that it's moved away from the group's location, which is the same as the elbow. So let's do the same for the others. The target is going to be here at the elbow. So I just snap that there. The up locator, I'm going to snap that to the wrist as well, or to the hand joint, and then I'm just going to move it out. That's arbitrary how far. It really doesn't matter. I'll just move it out on this thumb side. It looks like my y-axis, I'll just set it to 5. Again, it really doesn't matter what it is. Just make sure you move it out. And I said before too, you can do it up, down, you can do it front, back. That part doesn't matter. You just can't do it further down the x-axis. It has to sit off to the side. And hopefully that will become clear when we set up the aim constraint itself. Okay, and then lastly, we have this mid locator, and I'll just leave this in place for now. We will come back to that. Okay. So let's go ahead and get all of the constraints set up now. So, if we go back to the notes, if we're thinking about the target locator to start with, that one is supposed to be constrained to the elbow, so it follows the elbow. I'm actually going to put a constraint on the group rather than directly on that target constraint, because the target locator, because the target locator is a child of the group. If the group follows, the child will follow as well. The convenience of this, I could add it just to the locator, but the convenience of this is all of the locators will move with the elbow as well once I get this set. We'll do a scale locator as well, so in case the rig should scale, then all of the locators will scale in the same proportion. So the end result is the same because of hierarchy. We will constrain the parent group to the elbow, and we won't put any additional constraints specifically on the target locator, so it will follow what the parent does. All of the remaining locators, we will put constraints on those. So you remember, constraints have priority over hierarchy. So they will follow the constraints where values are constrained, but if they're not, then they'll just follow whatever the parent node is doing, which is essentially it'll follow the elbow. So let's just start by taking the RK elbow joint, and I'll control select the twist group there, and we'll do both a parent and a scale constraint. And just to show you what I mean, if we bring back the controls, let's do this too. Let's take our locators here, and actually we'll take the mid locator too. Rather than scaling them up, I can, but that puts transformation values on them. If we go down in here to the shape node, the local scale, this isn't the transformation value, this is just the scale of the shape node itself, not the transformation. So you can see I'm making the locators a little bit bigger here so we can see them a little better. And if I take and just move the IK control, you'll see that ignore this one. This is our mid control that we left down at the origin. That's moving along with it because it's part of the group, but we haven't put it in place yet. So just ignore that for a second. But you can see all of those locators are moving just like the elbow. They're locked to the elbow. Okay, which is exactly the behavior we want. Okay, so that takes care of the target locator. I'll just move that up to say that's taken care of because the transformations are taken directly from the constraint put on the parent. Let's worry about the up locator next. That one is going to be parent constrained to the hand joint. So we'll select the hand joint here. This is not the wrist joint. That's part of the arm, but the hand joint. And we will control select the up locator, and we're just going to do a parent constraint there. Okay, we don't have to do a scale constraint because the scale for these is locked to, well, I shouldn't say locked. It's adopted from the parent group, which does have a scale constraint on it. So again, if the arm does scale up, this group will scale up with it. So we just need that parent constraint so that it is locked to the hand joint, okay? And if we just take the hand joint here and twist it, you can see that the up locator is moving along with the hand. Okay. Next, we'll deal with the aim locator. So if you remember, that's going to be a point constraint. I want that locked to the same position as the wrist, but the rotation we're going to take care of with the aim constraint. So again, we'll select the hand joint, and then I'll control select the aim locator over here in the outliner, and we'll just do a point constraint. So now if I move the hand, you'll see that this locator here is following. Okay, that's the aim locator, but you'll notice that if I rotate that hand control on the joints, that no rotation occurs. Okay, we'll go ahead and reposition that back to its default state there. Okay, so now we're going to set up the aim constraint. Okay, we haven't really worked with aim constraints before, so just to demonstrate, let's just go into a front view. Where are we? Okay. And let's create a couple new locators. One. Let's put it here. Let's turn off the grid. And let's duplicate this and move it over here. And I'll duplicate it one more time and just move it up. So this will be called target. This one will be called aim. And this one will be called up. So let's bring up the options for our aim constraint. And this one gets a little more complicated. Let's reset our settings. Okay, maintain offset and the offset values. It's the same as the other constraints. If you want them to stay in their current rotations, even if they differ, then you go ahead and turn maintain offset on, and it will automatically add values for you to ensure that that offset between the two nodes remains the same. But we don't want that. We're just going to leave that off. We're going to come down here to the aim vector. So this is going to be in some ways very similar to, at least similar thinking to orienting our joints. We're defining an aim direction and we're defining an up axis. Okay, it's really, it is quite similar. The aim vector, let's look at our node here. I am in a local space. So I want, in the same orientation it's at right now, I want this side that's already pointing in that direction, I want it to continue pointing back to this target locator. So if I look at the orientation of this object, you can see X is pointing to the right, which means this is going to be a negative X value pointing back in the right direction, okay? The difference between this and joint orientation is it doesn't matter what axis is pointing. You just have to choose one, okay? You can aim any axis you want at another object. We have a very specific case, and we're actually using the same orientation that our joints are in. So there's a specific axis we need to choose, but just know that an aim constraint, really, you can point or aim at another object with any axis. So we're going to take kind of this orientation that's already in, and we're going to use that. So X is pointing, positive X is pointing to the right, so negative X should be pointing towards the target locator. So in my aim vector, I want to say -1, 0, 0. So it's going to create a vector pointing in the -1 direction coming out of this aim locator, and that's what has to point to our target, okay? Next, we have our up vector. If we were to bring up the orient joint tool, the secondary axis is like the up axis, right? We select the axis we want, and then we tell it what direction, which world direction we want to point it in. So same thing really with our aim constraint. We're defining our secondary axis or our up axis. So I'm going to be using the Y positive axis because it's already pointing up towards this up locator. So my up vector is Y, so 0, 1, 0. All right, that would be up in the Y axis. And then for world up type, we can actually change this to several different options. When we go back and think about the world up orientation in joint orientation, it doesn't say it, but it's actually in this, well, I guess it's more of a vector up position. And, it just says XYZ. positive or negative. And you could set this by hand. Right now this is set to y positive because y is set to 1, right? If I wanted it in y negative, I just set that to -1. Okay, but we're going to not use the world coordinates or any orientation with the world. Instead, we want to use an object's position more specifically. So I'm going to change this from vector to object up. And what this means is the vector that I choose here on the constrained object is going to point at whatever object I specify in this field. So I would actually have to come and take the name of this. So this is pretty simple because we just called it up, but I would need to paste that into this field. So again, this is saying, oh, and I messed up on the aim vector. Sorry if that was confusing. This should be -1. Okay, so I would select the target and then the aim locator, and then we'll think this through one more time. I'm saying I want the negative x-axis to point at the target. I want the up vector to be the y-axis, and I want it to point to the object called up, which is right here. I don't have to select the up object. I just have to actually list its name here in this field, and I'll hit apply. Okay, and nothing happened, and that's because my object is already initially oriented exactly the way I want it. But now we can actually try this out. So as I move the target object, you can see that my aim object rotates to meet it. Okay, we'll have to go into a different view to look at the twist. Okay, so it aims at my target, and then if I take this aim locator, you can see that is going to control the twist. Note that that x-axis never varies. It's always pointing directly at the target. Okay. However, I'm able to affect the twist using this locator object, this up locator object. And again, this is kind of where the magic of the system is. We're going to tell the locator at the wrist, which will control the joint, to always point directly back to the elbow. We always want it pointing at the elbow. But we're going to manipulate the up axis. This is what is actually going to follow the twist of the hand control, right? And we'll be able to take that rotation value on the aim locator and add it back to the joints. So this locator, it's never going to do this bend. It's never going to bend up or down or left or right. It's only ever going to twist, which is what we want. Because remember, we've got two different behaviors there that we're trying to delineate between. Because again, the up, down, side to side, that is focused only or isolated only here at the wrist, whereas the twist goes all the way up through the elbow. So we're isolating the twist with this locator system. And again, we'll manipulate that more directly with this up locator. Okay, so this is the system that we're setting up right now. So let's go back up here to the arm. And let's do the same thing. So if we look at our locators right now, we've set them up so that their orientation is the same as the rest of the arm. So this locator here, you can see X is pointing over to the right. That's the positive direction. Because these are all oriented the same, we know that negative X is going to point it directly back here to the elbow. And I moved the up axis forward in the scene view, which you can see is a positive Y transformation. So that's going to be my up axis, is the Y axis. And then I want it to follow this object. So I'm just going to copy the name of this object right now, left arm twist up locator. All right, and then let's set this up. So again, I'm going to select the target first, and then the aim locator. And then we'll go to our aim constraint options. And my aim vector should be -1. So I want it to point back towards the elbow. My up vector conveniently is still positive Y. Now remember, positive Y does not represent the world direction. It's just saying on my object, my positive Y, because of the way it's oriented, positive Y is facing forward in the scene. So I'm speaking about the local axis. Okay, let me select these again. Target, aim. So I'm saying I want the local y-axis to point to this object, left arm twist up locator. So that's this object right here. Okay, and let's go ahead and just add that in. And you should not see any rotation values because everything's already exactly the way it should be. So no values should be added there. Okay, and again, we want to verify that this is working. Okay, you can see that that locator is always aiming, the aim locator is always aiming directly down to the elbow. Okay, you can see that the elbow, the target locator is locked to the elbow, so it's always going to stay in that position. Okay, and you'll see that our up vector is always staying oriented with the wrist. I haven't rotated the wrist at all, so it's just staying locked horizontally. If I did want to rotate, I can rotate the IK control, because remember that's that's also rotating the hand control, or I can just go rotate the hand control directly. Okay, same effect. And you can see now when I rotate that, that is, let's hide the controls for a second. That is going to rotate the pole vector about the same pivot point. I'm sorry, that's going to rotate the up locator about the same pivot point because it's been constrained to that hand control. And because the aim locator, this y-axis, which is right here, is trying its best to point back towards that up locator, you can see that we're getting that twist in the wrist. Okay, I can rotate down this way and nothing's going to happen because the locator position hasn't changed, right? This way I can go too, but really the locator position, the up locator position hasn't really changed. It's still in line with the arm, right? So we're not getting any weird transformations in the wrist. It pretty much just stays in place. So the magic is there. Again, if we were just to move this and look at our aim locator, all of the rotations are going to be isolated just to that x-axis. X is pointing right back to the elbow, and so as we change the that up locator, all we're doing is twisting along that x-axis. So we've been able to isolate one rotation value for the wrist component. So let's undo that again. So, I mean, really, we're just about there, okay? What we want to do now is grab that mid locator down here that we left down at the origin, and let's put that right between the target and the aim locator. And the easiest way to do that is let's just select target and aim, and then lastly we'll select the mid locator. And we're going to do a point constraint, but let's turn off maintain offset. And that's going to bring it up. I've got two targets on one object. Maintain offset is turned off, which means they're both going to share the same amount of weight. So with a point constraint, what that's going to do is bring it up and put it directly in the middle of the two controls. So I'll just hit apply. Okay, and that's put it right in the middle of the two targets. If I were to move one of the targets, you see that would always stay directly in between the two, which again is exactly what we want it to do. Okay, and right now, it's got a point constraint on it, but it has no rotation constraint or values of any kind. So because I don't have any constraints on it, it's going to follow the hierarchy, which means rotation is going to be exactly the same as the elbow because the parent was constrained to the elbow. All right, so if I were to move this around, you'll see it just looks like it's part of that, the arm is part of the elbow. So this is where we want to take a scalar value on the rotation of this aim locator. We want to take 50% of the rotation and we want to connect it into the X rotation value of this mid locator. So for this, we're going to bring out our trusty node editor and introduce you to a new node here. Okay, we're going to load up the aim locator. So let's select aim and I'll hit that plus button there to bring that into our scene. And we'll also load in our mid locator. So plus, and we'll just add that in as well. Let's see, we don't really need these shape nodes. I can just select those and hit that minus button. Select both of these. I'll press 3 to expand them so we can see them a little bit better. So again, the only thing I want this joint to do, its position should always stay exactly where it is. The only value I want on it is an X rotation value. I want it to do the twisting halfway down the arm. If I wanted to, I could take the rotation of the aim locator, rotate X, and I could pass that directly into the mid rotate X. So this is our output. I'll plug that directly in. And you'll see now as I twist the wrist, it's taking whatever the values are of this locator, the rotate X value, which is 53.2, and it's plugging it into the X value of the mid locator, so 53.2, okay? Which is great, except again, as we looked at the arm and we twisted it, we saw it's like 100% influence at the wrist, about 50% halfway down the arm and 0 down at the end. So we're going to add a little scalar value in between here. So I'll just, in my node editor, I'll hit tab and I'll start typing in multiply divide. Okay, and this is a node that does those two things. It will either multiply or divide numbers together. And let's go into the attribute editor really quick. Attribute editor will let you select between a few operations. Okay, it does nothing, it multiplies, it divides, or it raises something to the power. And you have an input 1 and an input 2, and an XYZ for each of those. So what it's going to do, it's going to take the X value of input 1 and perform whatever operation you have here with the X item of input 2, and then it's going to export it as the output X. Then it'll do the same thing for the Y's, and it'll do the same thing for the Z's. I only need one, okay? We're just gonna do one of those. We don't have to worry about the other two numbers. We're just going to multiply our rotation value. So let's just take our let's give this a name really quick. Left arm twist, multiply, divide, MD. Okay, we'll expand this. And I'm going to take rotate X of my aim locator, and I'll put that as my input X. Okay, that adds this little unit conversion node. You don't have to worry about that. That's just some behind the scenes stuff. Okay, let's select the multiply divide node again. I'm going to set the operation to divide, and I want to divide that by 2, right? That's 50%. Likewise, I could multiply by 0.5, which is 50%. They both do the exact same thing, okay? I'll just divide by 2. I think that's probably easier for those who don't care for math, dividing by 2. Okay, so that's going to take my rotation value and divide it by 2, and then it's going to return that value in my output X channel. And my mouse is super slow and jittery for some reason. Come on, mouse, there we go. So output X, I'm going to hook that directly into the rotation. Oh boy. Sorry, something's slowing my computer down here. There we go. I hooked that directly into the rotate X channel of my mid locator. And again, it puts a little unit conversion node in here. Okay, you don't have to worry about that. Just let it do its thing. And now check this out. If I rotate my hand, I've rotated 86 degrees. You can see the mid locator now has only rotated 43 degrees. So it's only rotating half. You can see that there, right? It's rotating half of what that aim locator is rotating. That's locked to the hand control. Okay, so from there, we're pretty well done. Now we just have to create some joints, and we'll constrain them to these objects and add them to the joint hierarchy, and it's done. That's what we will skin those parts of the arm to. So reset the hand control, and let's add a couple additional joints here. So let's just grab our skeleton tool, create joints, and I'm going to create a new joint here at that mid locator, and I'll create an additional one down here at the wrist. So now we have 3 at the wrist in the exact same place. Okay. Let's call these left arm twist 01 joint and twist 02 joint. And we're going to make both of these a child of the elbow, the RK elbow. So I hit P. Let's take a look at our hierarchy now. Okay, you can see that they do not fall into a parent-child relationship, the twist joints themselves, right? They're both children of the elbow joint. And the reason we do that is when I twist the elbow joint, I don't want that to twist the second twist joint. Excuse me, I called it the elbow joint. When I twist joint 1 here, I don't want it to twist joint 2 just because it's a child. I want it to maintain its own rotation values based on the constraint that we're going to feed into it. So we'll just leave those both as children of RK2, and maybe I'll move those up so it's a little more obvious what they're doing here. We'll just put them up to there. So that's the exact same hierarchy. I just moved it so that the other sibling nodes weren't separating it. Maybe I'll put RK3 right here. I don't know what's easier to read for you guys, but that's all exactly the same, okay? Then I'm going to take the mid locator, okay, and I'm going to constrain the twist joint directly to this locator. So we'll take the locator here and the twist joint, so mid locator to twist joint, and let's go ahead and just do a parent constraint. Okay, and again, just to verify that this is working, let's go ahead and just rotate the hand, and you can see that joint now is only rotating that 50% of what the hand itself is rotating. Okay. And then the twist 2 joint, we're going to constrain that one directly to the aim constraint. So let's take aim constraint, twist 2, parent. Okay, and maybe we'll increase the scale of that so we can see that a little bit better. No, I'm sorry, not the scale, but the radius. Okay, and again, we'll twist our hand control, and you can see that outer joint, which is our twisting joint, is rotating. Okay, and hopefully we can view this as I move up and down. You can see the hand joint moves up and down, but the wrist does not. As I move side to side, same thing. But even with it in this, now I've rotated it down and to the side, and then I can twist it, and you can see I'm getting twist in the forearm and I'm getting twist in the wrist. So it's a super cool system. It does a lot of, it's some kind of complex stuff that's going in there because of all the amazing bones and musculature that we have in our forearms. But now it's completely automated for the animator. They don't have to worry about any of that. All they have to do is animate the arm and the hand. So again, verifying that this works, you can see I can move the arm. If you just watch that mid locator, you can see it's not rotating. It's just staying in line with the rest of the arm. Occasionally, you can see when I move my hand in like this, the IK handle, because I've oriented that last joint to the IK handle, I am starting to get a little bit of twist in the wrist just because of the way that I'm positioning the arm. Right, and you see that twist kind of comes out as well. But the system works really, really well. It's very robust. The only caveat to the system is if you were to take and rotate this all the way down and upside down 180 degrees, you didn't see it there, but once you hit 180 degrees, this mid locator actually flips the other direction. And that's because Maya, instead of saying, 90, 150, 170, 180, instead of going 190, 210, 270, it says 180, negative 170, negative 120, negative 130. And so the rotation of this joint actually, or this locator actually flips back a different direction. So that's just kind of one of the caveats. Don't go beyond 180 degrees. Go ahead and reset that. And we'll reset this as well. Okay. If I were to go in and look at my geometry now, let's go to front view. We can I know we're not skinning yet, but we can kind of see this working on the proxy mesh. I'll just need to select my geometry here, and let's create a new cut. Let's use my multi-cut tool. Let's just draw a cut right more or less where this joint is. Actually, let's space it out a little bit. Do one here, do a slice here as well. Let's go ahead and select all of these faces, and we'll delete them to separate the two objects. And then I'm going to do a separate command to separate everything, all these sub-objects into their own piece. I'm going to reconnect these, so we'll do a combine on those objects. So we've got kind of the upper forearm and the lower forearm. So let's go ahead and unparent them really quick so they're not inside of any kind of leftover hierarchy that was right here. Let's go ahead and select them both and delete their history. It gets rid of those extra unnecessary group nodes or transform nodes. Let's rename them. So let's see, what did I call this? Left arm 01 proxy. So we'll just call this left arm 02 proxy geo. And I'll just call this 3. Left arm 03 proxy geo. And let's go ahead and put them back up here into our proxy geo group. Oh, it looks like it didn't get rid of one of these groups. Let's get rid of that. So it renamed my O2 proxy geo because it found a similarly named object. We'll bring that right up here. Oh, I found this mistake earlier too. I forgot to rename my right side. Not that this matters, but I don't want to cause confusion in my file here. I should say not that it matters for this particular example that we're showing. So here we go. We've got the proxy 2 geo. I'm just going to constrain that directly to our RK elbow, just like it was before. So parent scale constraint. And then we'll take this proxy 3 geo, and I'm going to constrain that to our joint 1 twist joint here. So I've got that joint selected in the geo. We'll do a proxy and a scale. And when you skin, this is essentially that's what you're going to do. You're going to skin the elbow 100% right here to the RK joint, and then right here in the middle where you have edge loops here, that's going to be skinned basically 100% to this mid joint, and then you're going to smooth or gradate that weight between these two. And then down here to the upper end or the right end of this upper arm, that's going to be weighted to the twist 2 joint. And then you're going to blend the weight between twist 1 and twist 2 joint here in this area. And then lastly, for that deformation for the wrist, the hand, obviously, and the fingers from the right side of this joint moving forward, the hand joint is going to influence all of this area of the hand. And then that really focused local influence between the two, between the wrist area here where the creases are formed, you're going to paint weights here between twist 2 joint and the hand joint. But again, just to verify that this is working the way we hoped it would, let's go ahead and hide our joint layer. And we'll show our controls. We already were showing controls. And let's just twist. Let me show the wireframe here. And we'll go ahead and twist the wrist. Okay, and you can see that the hand is rotating faster than that lower part of the forearm. Again, we're dealing with proxy geo, so it's kind of an approximation. It's not perfect, but hopefully you get the idea there. we were to take the IK control here and go one step further and actually move the arm, oh, guess I forgot to constrain that. It didn't matter because it wasn't moving. Let's try that again. RK joint and the geo. Uh-oh, what did I do wrong? Oh, I went backwards before. I messed up and I constrained the joint to the geometry. I don't want to go back and undo this. I don't want to leave that target there. That's kind of a no-no because it's going to waste resources. So again, do what I say, not what I do, just because I'm going to have to go back quite a bit in order to fix this. I'm just going to, no, yep, I am. I'm just going to set this to 0 so that that target has no effect on this constraint. Again, that's not the right thing to do. It's just for sake of time, we're just going to turn that off. No, I can't even do that. I just realized I can't even do that. It will still create a cycle. I'm just going to have to undo until, there we go. I guess it wasn't that far back. I just was talking too much. Let's try that again. Joint to geo, parent. Oh, I didn't go back far enough. It's still in the parent constraint. Let's go back a little further. Now it's gone. Okay. And you guys saw I was getting that cycle error and the rig generally blows up. So I do it too. Just watch when that yellow bar comes up that you got to stop and say, oh, what just happened? I need to fix it. So here we go again. RK joint to geometry, parent, and scale. And then we're going to say twist 1 to that proxy 3, parent, and scale. Okay, and now let's go back in and try to verify that one more time. Okay, you can see the arm is functioning like it should. If I bring this wrist down here and I start twisting it, you get that partial rotation in the forearm. Okay, and once we skin this up, it's going to look super awesome. You can see you still get that bending up and down and to the sides with your wrist, and it looks pretty normal. So pretty normal. That's what we're going for, pretty normal. So again, just to review, we'll go back to our whiteboard here. We're creating, really it's 4 locators. Our target, which is point constrained to the elbow. It's parent constrained to the elbow, but really it's via that group node, okay? That the whole parent group for all of these locators is has the same orientation and position as the elbow. And then we can snap the target locator to the elbow. We'll snap the aim locator to the hand joint, and the locator we're just going to move off in one direction. I chose to move forward. You could move down, you can move up. It really doesn't matter as long as you get your up target set up correctly and define your up vector correctly to point at it. The target locator is held in place via a parent constraint on the group node. The aim constraint is held into place via a point constraint to the hand joint, and an aim constraint for orientation, an aim constraint that aims back to the target locator, and the up locator uses that object up as the up type. Well, I'll look again. I can't remember what that's called. And it points its secondary axis or its up axis at the up locator. The up locator is constrained to the hand joint. So basically it gets the same rotation or orientation as the hand joint itself. The mid locator, we just use a point constraint with maintain offset turned off so that it is snapped exactly 50% between these two locators, the target and the aim locator. And then we use that multiply divide node and we plug in the X rotation of the aim locator, and we divide it by 2 or multiply it by 0.5, which does the same thing, and then we feed that output value back into the rotate X channel of that mid locator. And then last thing we did was create those joints, right? We had some additional joints here. We had the twist joint here, Well, they're going to be magic joints, magic rainbow joints. Right, and one here, and those are both children of the RK joint itself, like that. And then we just constrain those joints directly to the mid and the aim locator. So they will, and we do a parent and a scale. So they're going to get both their positional, rotational, and scale values from the locators. So what's cool about this system too is it works in the legs as well. You do the exact same thing down here in the leg from the knee down to the ankle joint. Because the reality is quite the same for your foot. When you rotate your foot up and down, or you rock it side to side, that's happening from the pivot point of your ankle. But when you twist it, when you do this action, we've got this pull vector thing set to IK control, so that worked better than it should have. But when we do this action, you're actually rotating not your ankle, but that rotation goes up your leg towards your knee. The exact same idea. So that system works awesome up there as well, or down there rather in the leg. But same thing, you set up a target at the knee and aim at the ankle, and then you can put your up locator probably out here to the side. Your mid locator is going to go right in between the two joints, and you set it up exactly the same. So I hope that makes sense. This is one of those parts of the rig. You get to the point that we got to before today, and you're like, sweet, my rig works great. And you don't realize until you animate it some of these other little nuances where you're like, oh my gosh, this wrist looks terrible. No matter how I skin it, it looks terrible. And it's not uncommon for early rigs, or for those who don't really know how to rig, it's not uncommon to see this in their animation, and they just don't know how to deal with it. So again, once you know how to do it, it's an automated process that will make all of your characters look amazing. If we have the time, I'll show you how to do a very similar thing up in the shoulder as well, because we have the exact same issue happen in the shoulder, especially because it's a ball and socket joint, and it has a tendency when you want to twist your arm at certain angles to also do that candy wrapper type of deformation. But that's it, okay? I'm going to, as an assignment, I'm going to have you guys implement this into your rigs. So you'll be doing this for both of your arms and both of your legs. Unless your specific character, this doesn't work as well. The one I can think of right now, because I've seen Steve's character and we talked about it in class last time, the back leg, that quadruped character, that might be a little harder to implement on that character because of the spring IK. But because you've done the spring IK, you've added additional feature, and the behavior of the leg is actually a little bit different, just because of the nature of that creature. So again, if you have a specific case where this perhaps isn't going to apply, contact me, let me know, and we'll talk it out. But the idea here is I just want you to continue to up the level of your rig for this character that you have. So, if it's not this, it's something else. And again, using Steve as an example, it's not this, but instead it's implementing the Spring IK solver. So you are upping your rig level, your rig quality and complexity, and making your animator's life a lot easier. So I will get the assignment up for that. But again, that is the expectation. I would like you guys to have that finished by Thursday. On Tuesday, we'll talk about any questions you have with this, and then we will also start into blend shapes. But I am giving you a little extra time. I'm giving you a week. One, because this is a recorded lecture and you haven't been able to ask questions yet. Two, so you can ask questions and get it right by the time next Thursday comes around. But as always, don't wait. Please don't wait. If we get there on Tuesday and you haven't tried it, you're not going to have questions to ask. And then Wednesday, you're going to stay up till 3, 4, 5, 6, 7 a.m. again, trying to get this thing finished up. So you've got a whole week let's not even say that. You've got like 4 days until Tuesday. You should be able to start building this and get your hands wet, get your hands dirty, and get your feet wet. I'm so good at idioms, especially when it's late at night like it is right now. So anyway, best of luck. I will be on the road, but I think I can kind of be texting things back and forth if you guys do have questions. Just go ahead and let me know. Okay. Thanks, guys, and we will see you next week on Tuesday. Okay. Bye.